Hello everyone. Today we are going to find the shape factor for an unequal eye section. You can see that this eye section is unsymmetrical. In this eye section, all the dimensions are given. In the top flange, the breadth is 240 mm, thickness is 20 mm. In the bottom flange, the breadth is 300 mm, thickness is 20 mm. The thickness of web is 20 mm. Overall depth is 240 mm. We know that the shape factor formula S is equal to Zp by Z. Here Zp is the plastic modulus, Z is the elastic modulus. First let us find the elastic modulus. The formula is I by Y max. In this I section, first let us find the location of the centroid from the bottom. Let us keep the bottom flange as 1, the web as 2, the top flange as 3. The depth of the flange is equal to 240 minus 20 minus 20. We will get 200 mm. Now let us find y. The formula is a1y1 plus a2y2 plus a3y3 by a1 plus a2 plus a3. a1 and y1 we must calculate from the bottom flange. a2, y2 we should calculate from the web. a3, y3 we must calculate from the top flange. Area 1 is equal to 300 into 20. We will get 6000 mm square. Area 2 is equal to 200 into 20. We will get 4000 mm square. Area 3 is equal to 240 into 20. We will get 4800 mm square. y1 is the distance from the centroid of the bottom flange to the bottom fiber. We know that it is a rectangle. In the rectangle, the centroid will be in the center. To find the center, we have to divide 20 by 2. So y1 we are getting 10 mm. y2 is the distance from the centroid of the web to the bottom fiber. The web is also a rectangle. So the centroid lies in the center. To get the center, we have to divide 200 by 2. So from here to here, 200 by 2. But we need the distance up to the bottom. So we have to add 20. When we add 20, we are getting 120 mm. In the same way, we have to calculate y3. The top flange is also a rectangle. So the centroid lies in the center. To find the center, we have to divide 20 by 2. From here to here, the distance is 20 by 2, but we need the distance up to bottom. So 20 by 2 plus 200 plus 20. After adding all of the values, we are getting y3 is equal to 230 mm. In this formula, we have calculated all of the values. We can apply them. Finally, we have found the position of the centroid, that is 111.08 mm. We have calculated this value from the bottom of the eye section. Now we can calculate the moment of inertia. We have already seen that we are having three parts: the bottom flange, the web, and the top flange. So we have to divide the formula into three parts. In the formula, for the first part, breadth is 300, depth is 20. Also we have calculated a1, y1. We can apply the values. For the second part, breadth is 20, depth is 200. Also we have calculated a2, y2. We can apply all of them. For the third part, the breadth is 240, depth is 20. Also we calculated a3, y3. We can apply all of them. After the calculations, we are finding the moment of inertia. Now let us find the y max. Below the neutral axis, we are having 111.08 mm. We have to calculate the distance above the neutral axis. So 240 minus 111.08, we will get 128.92 millimeter. We can compare both of these values. This value is higher than this value. For y max, we have to select the higher value. This is higher. So y max is equal to 128.92 mm. In the elastic modulus formula, we have calculated I and y max. We can apply both of the values. Finally, we have found the elastic modulus Z. Now let us find the plastic modulus Zp. The formula is A by 2 into y1 bar plus y2 bar. A is the area. Previously, we have calculated area 1, area 2 and area 3. We can add 3 of them. Finally, we are getting the area. For calculating y1 bar and y2 bar, we have to find the location of the equal area axis. This I section is not symmetrical, so it is not easy to find the location of the equal area axis. Let us assume the equal area axis occurs at a distance of h from the bottom of the top flange. We know that above the equal area axis and below the equal area axis, the area will be same. The total area should be divided into two equal half areas. Now let us find the value of h. The total area is 14800 mm square. Here we will have half area. So A by 2 is equal to 7400 mm square. Now let us equate the area of this part with the half area. Here the area is 240 into 20 plus 20 into h. In this way we can calculate h, which is equal to 130 mm. Now we have found the location of the equal area axis. The equal area axis lies at a distance of 150 mm from the top and at a distance of 90 mm from the bottom. Now let us find y1 bar and y2 bar. We have already split the whole area into two equal half areas. Let this area be area 1 and let this area be area 2. We have to be very careful. Y1 bar and Y2 bar should be calculated from the equal area axis. Now let us calculate Y1 bar. For that we have to take the area 1. We already know Y1 bar should be calculated from the equal area axis. Here we are having two parts, the web and the flange. Let us keep the web as 1 and the flange as 2. Y1 bar is equal to A1 Y1 plus A2 Y2 by A1 plus A2. Area 1 is equal to 20 into 130. We will get 2600 mm square. Area 2 is equal to 240 into 20. We will get 4800 mm square. Y1 is the distance from the centroid to the equal area axis. This web is a rectangle. For a rectangle, the centroid will be in the center. So y1 is equal to 130 by 2. We will get a 65 mm. y2 is the distance from the centroid of the flange to the equal area axis. This flange is also a rectangle, so the centroid lies in the center. To get the centroid, we have to divide 20 by 2. Then we have to add this 130 to find y2. Finally, we are getting 140 mm. In this formula, we can apply the values of a1, a2, y1 and y2. After the calculations, we are getting y1 bar is equal to 113.65 mm. We have calculated y1 bar. Now let us calculate y2 bar. For calculating y2 bar, we have to take the area 2 from here to the equal axis. The distance is 130 mm. So 200 minus 130, we will get 70 mm. We have to calculate y2 bar from the equal axis. Let us keep web as 1 and the flange as 2. Area 1 is equal to 20 into 70. We will get 1400 mm square. Area 2 is equal to 300 into 20. We will get 6000 mm square. Y1 is the distance from the centroid of the web to the equal axis. The centroid lies in the center, so 70 by 2, we will get 35 mm. Y2 is the distance from the centroid of the flange to the equal axis. So Y2 is equal to 20 by 2 plus 70. We are getting 80 mm. In the Y2 formula, we can apply the values of A1, A2, Y1 and Y2. Finally, we are getting 71.49 mm. In the plastic modulus formula, we know all the values. We have calculated area, y1 bar and y2 bar. We can apply all of the values. Finally, we are getting ZP. In the shape factor formula, we can apply the values of ZP and Z. The value of ZP just before we calculated the value of Z we have already calculated. We can apply both of the values. Finally, we are getting the shape factor S is equal to 1.23. Now we are going to end this session. Thank you for watching this video.